So I'll start today with the most important topic, and in fact, these are the tips which I'm going to share with you, and that is basically how to score perfect marks in chemistry. Now, see, the most important part right now is when you are actually trying to prove anything or trying to find out anything in this part, it's very easy because the syllabus has been cut down. The most important thing is this is the syllabus for 22-23, where solution is of 7 marks, electrochemistry is the maximum of 9 marks, although I have heard that few of them they are saying that in the sample paper itself it is given as maybe 8 marks, but and aldehyde and ketone is of 9 marks. But as such, the syllabus or as per the syllabus, I'll say it is 9 marks, chemical kinetics 7 marks, DNF block 7 marks, coordination 7 marks, haloalkanes 6 marks, alcohol phenol ether 6 marks, aldehyde and ketone carboxylic 8 marks, amines 6 marks, biomolecules 7 marks, total of 70 marks. So we'll be discussing one by one. I'm trying that today. I will be able to finish up the organic portion and the questions which are very very important. The pattern of the CBSE question paper for 22-23 will be that there will be 35 question. Uh, there will be 35 question in the question paper, which of course will be divided into 5 sections. Of course, A, B, C, D, E, and all the questions will be compulsory. Although there will be few internal choices that will be given to you. For example, section A. Section A has all 1 markers, total 18 MCQs with no internal choice will be given to you. That means all the questions will be compulsory. The only point here is question number 1 to 14 will be MCQ type. There is, as such, I said, no internal choice will be given to you. And this is of course, 1 to 14, that is of 1 mark. 15 to 18 is of assertion reasoning question or assertion reasoning based questions. 1 into 4. This total comes out to be uh, 18 because it is a 1 marker. I've written 22, but it is 18 marks. Then section B will be having 2 markers. It will be from 19 to 25, total 7 questions. And of course, these are the questions which are called short answer type 1 questions. 7 into 2, 14 marks will be there. Then the next one is question number 26 to 30, total 5 questions. And there will be only two internal choices. Although when we have actually taken up the previous year paper, there will be the choices were actually more in number. Now the choices have been decreased. So it will be of total 5 into 3, that is 15 marks. The next is question number 31, 32, and 33. That means question number, uh, there will be 2 questions, and those 2 questions will be basically of what? Uh, your questions will be case based type questions. The next is 33, that was 31 and 32. 33 and 35 questions are long answer question, that is your 5 marker, I will say. There will be only two internal choices. That means out of the 3 questions there will be only two internal choices. One question will have no choice as such. So I am going to start the CBSE class 12th chemistry subject. Basically is divided into organic chemistry, physical and inorganic. As I said, I'm going to divide this into how many parts? 3 parts. So I'm going to discuss today with the organic portion. Let's start with the organic portion. Basically, the organic portion means the second book. That second book, haloalkanes and haloarenes 6 marks, alcohols, phenols and ethers 6 marks, aldehyde and ketones 8 marks, which as I said sample paper is saying it is of 9 marks, but it is of 7 marks. That's why I told you that is 34 marks. Amines 6 marks, biomolecules 7 marks, total of 33, right? That's the rough weightage as such. Now organic may there will be 6 most important things that we are able to as such concentrate. Number 1 is the all important naming reactions. I have already shared one of the PDF with you, that what all are the naming reactions that are important. Number 2 is all the distinguished test between the pair of organic compound. Number 3 will be 5 mechanisms that I'm going to discuss today also with you. The next is the reasoning based questions, and the last and final, the case base. Of course the conversions will be included, but most of the conversion that you will come across will be all on the basis of the naming reactions that you have already done. Now let's go to the next part, and let's start with all the important naming reactions. See, as per me, there are 10 main naming reactions, which include aldol and of course the cross aldol reaction, where the statement is not so important. The most important thing here is that we are supposed to write the reaction, of course, a balanced chemical equation. The second one is the carbylamine reaction. Then, of course, the Cannizzaro reaction. Then next is Clemenson reduction, Itard reaction, Finkelstein, Hell-Volhard-Zelensky reaction, Hoffman degradation, Riemer-Tiemann, and Rosenmund reduction. So I will be taking up slowly and steadily about all the naming reactions. Let's start with the naming reactions. Let's start. The first naming reaction that we have actually done, or we are supposed to discuss right now, is aldol. See, aldol is basically being given by the aldehyde or ketone which have got alpha hydrogen atom. So I'll take up a very simple example. Any two aldehydes, two similar aldehydes having an alpha hydrogen atom, whenever they are reacted with a base, then a base like NaOH aqueous, I can have KOH aqueous, I can have even barium hydroxide, because most of the cases people fail to predict the reaction that's basically called the barium hydroxide reaction, but it is of course the aldol only. The hydrogen will try to attack over here and this will try to attack over here. The product form will be basically a beta hydroxy aldehyde or a beta hydroxy ketone, right? So this is the product that I'll be getting. This is aldol product. It is, of course, you can check from here alpha, beta. So this is beta hydroxyaldehyde. Next, when you try to heat this, or you add concentrated H2SO4, H, OH from here, H from here goes out. I'll be getting CH3, CH double bond, CH aldehyde. That is but 2 in 1 ul. But 2 in 1 ul. This is a very important conversion which is basically being asked, but most of the time when this conversion basically is asked, has the starting material as CH3 CH2OH. That means it starts from ethanol. They will ask you to write down the conversion, or they ask you write down the conversion from ethanol. So you are supposed to first do or use PCC. Pyridine chlorochromate will convert this alcohol into corresponding aldehyde because it is a mild oxidizing agent, and finally you have to go to this conversion that of course I'll discuss later on. Now the next conversion is, or next reaction is the carbylamine reaction. When I'm talking about carbylamine reaction, in carbylamine reaction we have a primary amine, maybe a aliphatic or an aromatic amine, whenever is reacted with a base like KOH along with chloroform. I'm not writing a balance equation right now, but I'll be getting phenyl isocyanide or maybe alkyl isocyanide. Here it is, of course, your ethyl isocyanide, which have an offensive smell. This is your reaction, but you are supposed to write down a balanced chemical equation. The next is Cannizzaro. Cannizzaro is basically being given by aldehyde which do not have an alpha hydrogen atom. So they have a tendency to react. In fact, suppose I have these two and I'm going to write here a base like QH, your concentrated QH or NaOH. It shows a disproportionation reaction if I'm not wrong. That disproportionation says that it will be oxidized into a salt of carboxylic acid like potassium formate, and it will be oxidized into a carboxylic acid. Sorry, it will be oxidized into this and reduced into this product, that is COH, H, H and H, that is CS3OH. So I'll be getting potassium salt of carboxylic acid and I'll be getting ethanol. So this is basically reduction is giving me an alcohol, while your aldehyde is giving me a carboxylic acid on oxidation. Another example I can take up is benzaldehyde, which also do not have an alpha hydrogen atom, because if something has an alpha hydrogen atom, it will try to give you aldol. If one aldehyde which do not have an alpha hydrogen atom, so it will now try to again, if I'll try to do oxidation of this, of course in the presence of KOH concentrated or NaOH concentrated, I'll be getting this compound CS3 C double bond O negative and K positive, potassium benzoate, and here I'll be getting benzyl alcohol, because as I said so many times, one H will be added here, one H will be added here, so I'll be getting CH2OH. This is benzyl alcohol. So this is my Cannizzaro reaction. Next is Clemmensen reduction. Clemmensen reduction and Wolff-Kishner reduction are very important reactions for the conversion of carbonyl compound into a hydrocarbon. Here in Clemmensen reduction, we are using zinc amalgam with HCl. The simple thing here is, if I'll be adding 4 nascent hydrogen over here, so 2 will be added here, 2 will be added here. So I'll be getting CH2, and of course the water goes out. So that means if I'll have H and H here, so I'll be having H and H. That means formaldehyde will give me methane, acetaldehyde will give me ethane, and suppose I have propanone or acetone will give me propane. This is your Clemmensen reduction. Then Itard reaction. Itard reaction is a very common reaction which we have done in the aldehyde and ketones. And the most important thing is we have done it in the form of a flow chart, where I told you that if suppose I have toluene whenever is reacted with chromyl chloride CrO2Cl2 in the presence of carbon disulfide, I'll be getting an intermediate, but I'll just write here hydrolysis H2 oblique H positive will directly give me benzaldehyde. So this is basically called as your Itard reaction. Next reaction that I have is Finkelstein. Finkelstein is basically used in order to prepare the iodides. So it's basically called as an halide exchange reaction. So I'll be reacting it with the iodide, sodium iodide, right? And suppose CS3, CS2, Cl I have. This iodide will try to replace this chloride and it goes out. The solvent that we are using over here is nothing but it is any ether, right? The reason is this should be a non-polar solvent. I'll just tell you the reason why, but I'll be getting iodide as a product and NaCl will go out. This NaCl is an ionic compound. Whatever will be formed over here is insoluble in this, and that's it, precipitate or settled at the bottom, while this will remain as such. That's why we use here any non-polar solvent. This reaction was Finkelstein. Now let's go to Hell-Volhard-Zelensky reaction. If I'm talking about Hell-Volhard-Zelensky reaction, in that we have suppose any carboxylic acid which have an alpha hydrogen atom. See, we have already done that. This is suppose a carboxylic acid, and this is the alpha hydrogen atom which is highly acidic, because this carboxylic acid has a tendency to pull out or act as an electron withdrawing group. So this alpha hydrogen atom is highly acidic. So if I'll write here X2 with red phosphorus, now what will happen? The hydrogen will be removed from here, CS3, CH. I'll be getting here a halogen and of course a carboxylic acid over here. This is the product, that is alpha halo carboxylic acid will be the product I'll be getting. The function of red phosphorus is to stop the reaction at a monosubstituted product. If I forgot to write here red phosphorus, then the possibility is that this hydrogen will also be converted into a corresponding halogen. So that's why red phosphorus is being added just to stop the reaction at a mono-substituted or mono-halogen product. Next is Hoffman degradation, which is basically used in order to step down the reaction. Most important, because I'll be using this reaction in the conversion also. So the point is, here if I have a amide, and if this amide is reacted with Br2 and KOH, the simple point over here is this can be aqueous or alcoholic, anything, because now this group goes out and I'll be getting what? CS3, CS2, NH2. So I'm basically, this is a 3 carbon atom and I'm getting a amine that is of 2 carbon atom. So that's why it is called Hoffman degradation or Hoffman bromamide degradation reaction. That means it is used in order to step down the number of carbon atom. The next is Riemann-Tiemann reaction. Riemann-Tiemann reaction is basically used for the conversion of an aldehyde, or sorry, for the preparation of an aldehyde. We have phenol. Phenol is reacted with chloroform along with NaOH aqueous. Here writing this aqueous is mandatory. I'll be getting an intermediate first. That intermediate will be this, because in this reaction we'll be having a dichlorocarbene ion which is going to attack over here, and finally if you try to do the hydrolysis, you will be getting, or you can write NaOH also here, you'll be getting the product as OH with aldehyde, that is called 2-hydroxybenzaldehyde, or also called orthosalicyl aldehyde. The IUPAC name of this compound is 1,2,2-hydroxybenzaldehyde, or as I said, orthosalicyl aldehyde. And the last and final reaction is triple R, which is called Rosenmund reduction reaction, which is actually used in order to convert an acid chloride into the corresponding aldehyde, of course, again by reduction. So I'm going to write down the journal reaction. This is acid chloride, RCOCl, and I'm going to add here PD with BSO4, which is basically called as Lindlar's catalyst. And of course, as I said, I'm going to add here 2 nascent hydrogen atoms. This bond will be cleaved, H and H. So I'll be getting RCOH aldehyde and the HCl goes out. We have done so many times wherever or in the right hand side HCl is being removed, we are supposed to use here a base like pyridine, which is actually a base that neutralizes HCl to shift the reaction in the forward direction. Whether it is in the acylation, we have done it for amines, whether it is for alcohols, when you try to do acylation, we are supposed to use here pyridine as a base, which is going to neutralize this. So these are the 10 most important naming reactions that we have discussed so far. The next part is all the distinguished tests. Although we have already done, there are 10 reagents which are basically being used for the conversion of, or I'll say, sorry, in order to distinguish between the pair of organic compounds chemically. There are 5 most important characteristics that are always being taken care of whenever you are writing or whenever you are writing a chemical distinguish test. The most important thing is that whenever we are discussing about that, there will be 5 changes that are very, very important to be taken care of. Number 1, there should be either a gas evolved. Number 2, precipitation. Number 3, smell. Number 4, color change. Or number 5 can be the appearance of turbidity. So the most important thing and the most important right now, the distinguished test is the iodoform test. Iodoform test is basically when you try to add NaOH and I2 and heat it, the alcohols which contain the group called the methyl carbinol group. Which group? Methyl carbinol group. This group is basically called as the methyl carbinol group. So which contain this methyl carbinol group will always have the tendency to give you iodoform test, yellow PPT, CHI3. Here also, if you can see, we have a methyl carbinol group, and that's why they all are capable of giving you the corresponding iodoform test. So ethanol, propane 2-ol, pentane 2-ol, or maybe butane 2-ol, 1-phenyl ethanol, they all are capable of giving you iodoform test. But the compounds like this They don't have a tendency to give you iodoform test. They do not contain the methyl carbinol group that we all were talking about. The next is, suppose it is a ketone, then in that case we are supposed to take up compounds. When you are talking about a carbonyl compound, of course there we are supposed to see this methyl ketone group. That means, for example, if I'll say pentane 2-one and pentane 3-one, so in that case pentane 2-one will give you iodoform test. On the other hand, pentane 3-one will not give you the iodoform test. So I was just trying to tell you here is, if I'll say pentane 2-one, this is pentane 2-one, it has this methyl ketone group. But if I am talking about pentane 3-one, pentane 3-one do not have that methyl ketone group, and that's why it is not able to give you the iodoform test, because iodoform, remember, is an oxidizing agent as such. The next test that we are going to take up right now, or of course I'll say the next distinguished test, is Lucas test, which is basically used in order to distinguish in between a primary, secondary and tertiary alcohol. Suppose if you are provided with 3 test tubes, and in one you have tertiary alcohol, in another if you have secondary alcohol, in another you have primary alcohol. If you add anhydrous zinc chloride with HCl, which is basically called as the Lucas reagent, you'll, if you appear that, or if the turbidity appear immediately, then we used to say that it is a tertiary alcohol. If it take 5 to 10 minutes, then it is a secondary alcohol. And in primary, if you will not be getting any PPT unless and until you try to heat that substance, then there is a possibility that you will be getting I'll say a primary then you can say that it is a primary alcohol. The next is neutral ferric chloride test. Neutral ferric chloride test is basically being given only by your phenols. So basically this test is used in order to distinguish in between an alcohol and a phenol. I mean, if I'll say ethanol and phenol, so it'll say neutral ferric chloride test. So when I'm talking about neutral ferric chloride test, you have this C6H5OH and FeCl3. In this case, you will be getting this complex, which is of violet color, hexaphenoxyferrate, right? What is this? Hexaphenoxyferrate. So hexaphenoxyferrate is going to give you this hexaphenoxyferrate, oxidation number 3, is of violet color, and it is only being given by phenols. This test is being given by phenols. Although carboxylic acid do give this test, but they give buff color, or which is called as skin color. I am actually going to use this test only for phenols with alcohols or with even cyclohexanol. Suppose if I'll ask you, there is a sample paper question that if you are supposed to distinguish in between phenol and cyclohexanol, as I've written here, alcohol and cyclohexanol being weakly acidic, they do not form such kind of complexes, there will be no change in color, which is basically being observed. But of course, phenols do give this test. The next test is the test used in order to distinguish in between a aldehyde and a ketone, and it is basically called as tolerance test. Which test? Tolerance test. So tolerance test or tolerance reagent, if I am not wrong, is basically oxidizing agent. Tolerance reagent is an oxidizing agent that has a tendency to oxidize aldehyde into a carboxylic acid, but itself got reduced into silver mirror, which will be formed in the inner walls of the test tube, right? The test is only being given by aldehydes, but not by ketones. And the silver mirror will be formed in the inner walls of the test tube. So remember, formaldehyde, estaldehyde, benzaldehyde, and one exception, it's not exception, although formic acid is the only carboxylic acid which is also capable of giving you the tolerance reagent test, because we always used to say the formic acid has this hydrogen atom which is considered as an aldehydic hydrogen atom, and that's got oxidized by, of course, the tolerance reagent. So this is one test which is basically used in order to distinguish between aldehyde and ketones. The next is, or the next test that we are going to take up right now, is sodium bicarbonate test. I repeat, the next test that I'm going to take up is sodium bicarbonate test, a very important distinguished test that is used in order to, or in fact, in order to distinguish between a carboxylic acid and a phenol. Carboxylic acids have the tendency that they can decompose this sodium carbonate into into the corresponding, or I'll say carboxylic acid have the tendency that they can decompose sodium carbonate and will give you the brisk evolutions of carbon dioxide. In fact, carboxylic acid decomposes sodium bicarbonate, right, to give you the brisk evolutions of carbon dioxide. I told you when I was teaching you the carbon dioxide comes from here, because we used to ask this question in the Viva also, that carbon dioxide is coming from this portion or this portion. The answer is, because carboxylic acid is being a stronger acid, even greater than phenol, it has a tendency to liberate brisk evolutions of carbon dioxide. You are doing it, this test, actually from class 10th itself, and very important test in order to distinguish, as I said, between aldehyde, your carboxylic acid with phenol. One of the most important distinguished tests that you will come across is how will you distinguish between acetic acid and phenol, phenol and carboxylic acid, any carboxylic acid. It can be benzoic acid, it can be any carboxylic acid. So they have a tendency to give this test. The next is the carbylamine test. When I'm talking about carbylamine, all the aliphatic and primary amines have the tendency that when they are warmed with carboxylic acid, when chloroform in the presence of alcoholic QH, they have a tendency to yield isocyanide, which I've already discussed while I was discussing the naming reaction. This is NC, phenyl isocyanide, which has an offensive smell, has a tendency to give you the test. Of course, as I said, the test of carboxylic uh, for amines, but this test is given by both aliphatic as well as aromatic amines, like primary amine, sorry, that's aniline. Aniline can give this test, as well as ethylamine or methylamine is also. So these are the tests that that is very very important, distinguished test. Then the most important thing right now is, what are the reaction mechanisms that are the five most important naming the reaction mechanisms that are important are: number one, acidic dehydration of alcohol at 443 Kelvin to give alkene. Number one. Number two, acidic dehydration of alcohol at 413 Kelvin to give ether. Number three, acidic hydration of alkene to give alcohols. It is just reverse of what we have done it in the first one. Then, of course, aldehyde and ketones have the tendency to show you nucleophilic addition reaction, the mechanism of the nucleophilic addition reaction of carbonyl compounds, right? And then SN1 and SN2. When we are talking about SN1 and SN2 reactions, the mechanism, of course, is again very, very important. It can be in the terms of your any. Now, the next point that we are supposed to take up right now is how, or what are the important conversions that we will take up. The first conversion that I'm going to take up right now is, the important conversions are: number one, either to step up or to step down, right? Either to step up or to step down. The first is to step up, that is ascending the series. Ascending the series basically means what? When you try to increase the number of carbon atom. For example, if we want to convert methane into ethane, of course, Wurtz's reaction will be used in order to convert methane into ethane. So you are supposed to first do the chlorination and then finally apply with sodium, or sodium in the presence of dry ether, you will be able to convert this. Then methanol to propane 1-ol. I always used to say Grignard is a very, very important tool in order to step up the number of carbon atoms. And very simple, if I'm preparing a Grignard, formaldehyde always give you primary alcohol, acetaldehyde always give you 2-degree alcohol, and of course propanone or acetone will give you a 3-degree alcohol. So these are the conversion which can be straightforward being pick up while you are doing the conversions. One step I'll say. Then next is ethanol to but2-in-1-ol. I told you when I was teaching you aldol, जहां 2 कार्बन एटम से 4 कार्बन एटम्स हो रहे हैं, the straightforward and the best thing is when you have 2 functional groups. Now those 2 functional group can be what? What are the 2 functional groups? Basically, when we are coming across those 2 kind of functional group, it can be aldehyde or aldehyde, or it can be a aldehyde with alcohol or carboxylic acid with alcohol, double bond with something else. So when you have double the number of carbon atom with 2, then we always used to convert this into what? By use aldol in that case. Then methylamine to ethylamine. Of course, you are supposed to use HNO2 with HCl. These are the conversions that are important from the prospect of what? Ascending the carbon atom, when you are trying to ascend the number of carbon atom. But the next point is when we try to descend the number of carbon atom. We have now done only 3 reactions. Till date, we have done only 3 naming reactions by which we used to descend the number of carbon atom or decrease the number of carbon chain, which include number 1, your, which one? Number 1 is the decarboxylation reaction. So for example, if I want to convert ethanol to methanol, I have to convert into a carboxylic acid and then I have to use NaOH with calcium oxide 3:1 ratio. Then in the same way, any carboxylic acid, propanoic acid to ethanoic acid can be converted again by using the same concept of decarboxylation reaction. Then ethylamine to methylamine. The second reaction is Hofmann degradation or Hofmann bromamide degradation reaction that can be used. And then but2 into ethanol. The best part, ozonolysis is also used in order to step down the number of carbon atom. And of course, it's just opposite to that of aldol, I always used to say, because there we are going from 2 to 4 carbon atom, and here we are going the reverse of what? Converting the 4 carbon atom into 2 carbon atom. The next portion that we have to take up right now, of course, after convergence, is the reasoning based question. For example, presence of a nitro group at ortho and para increases the reactivity of halorine towards nucleophilic substitution reaction. One question, because of course it shows minus I effect only from ortho and para, not from the meta. It destabilizes the carbocation. N-butyl bromide has a higher boiling point than tertiary because branching decreases the boiling point. And next is when this question is asked about this plus or minus sign, that basically means that it's a racemic mixture. So of course, it is optically active, means that's why it is a racemic mixture. Haloalkanes react with casein to form alkyl cyanide as a major product, while AgCN form isocyanide as a chief product. Again the same. And my favorite question, why chlorine is a deactivating but still it is ortho-para directing? A very important question for the reasoning based questions. I have not included many questions over here, but still these are these questions that we have discussed just now are very important from chapter 10. Then we have few case based or paragraph based questions. A paragraph will be given to you. Now the question can be either in the form of your MCQs, or even they can be asked one word. As far as this year, it is basically the not the MCQ, but one marker will be asked. And the last assertion and reasoning based questions, where you'll be given 3 options A, B, C, D. For example, the carbon oxygen carbon bond angle in ether is slightly less than tetrahedral angle, and reasoning is due to the repulsive interaction. So here it is, the first statement I thought is incorrect, right? So that's why if you try to see, assertion is wrong, but the reasoning is correct because it is all because of repulsion. Then ortho and para nitrophenols can be separated by steam distillation. That's correct. Ortho isomer associate through intermolecular hydrogen bonding. I don't think so. It is intra. That means Assertion is correct, reasoning is incorrect, and that's a C option. Oxidation of ketone is easier than aldehyde. Carbon-carbon bond of ketone is stronger than carbon-hydrogen bond of aldehyde. Of course, again the D part, oxidation of aldehydes is easy, but not ketones. We were discussing this question today itself, and the most important point here is the assertion is incorrect, but the reasoning is correct that carbon-carbon bond in ketones is difficult to be cleaved in comparison to carbon and hydrogen bond of aldehydes, and this is the reason. Now I will be taking up the portion of physical chemistry, not today but of course in the next class.